Okay, so in this class we'll do the next two, 9.7, example 9.8. We have done these two in the previous class. After this you can give the test. Okay, so example 9.7. Listen carefully to this. As we do this, let me read the question for us. A girl of 40 kg jumps with a horizontal velocity of 5 meters per second onto a stationary cart. So please keep that word stationary, means the cart was not moving. The cart with frictionless wheel. Then the mass of the cart is 3 kg. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. So listen carefully to that. So here, as we read the question, let us put MA is equal to 40 kg. Is the mass of the girl. That's fine, SI unit in kg. And then MB, let us put as the mass of the cart, I think 3 kg. Yeah, R, the masses of the girl. Okay, this one is girl. And cart respectively, the cart with the wheel on which she jumps and moves. Okay, so this is the one. Now initially UA is the initial velocity of the cart. So the of the girl moves onto the cart with a horizontal velocity of 5 meters per second, means there is initial velocity of the girl. And UB, I'll read that, onto a stationary cart. Stationary means not moving, so initially the cart has no velocity, 0 meters per second. Are the velocities of the girl and cart respectively before interaction. That means before the girl jumps on the cart and disturbs it. That is the initial velocity. And V is equal to, once the girl jump on the cart and the girl will begin to have the same velocity, right? So that is only V. V is the okay, so what is her velocity as the cart starts moving? So is the velocity of, or is her velocity, what is her velocity as the cart starts moving? As the cart starts moving. So as the cart starts moving, V represents the velocity of the girl along with the cart. So the cart velocity also V. That is, you can write here in bracket, velocity of girl on the cart, both of them, after interaction. So after she jumps on the cart, velocity of the girl as well as the cart both will be having V as the final velocity. So let us write here total momentum after interaction. Means after the girl jumps on the cart will be the final one. Right side, this one. MA, VBA, but both of them final has same velocity. Girl also V, cart also V, so you can use V plus mass of the cart and B into V. Both have the same. VB, VA will not come into picture because both of them are moving along together, so same V. So if you take out the common factor, you will get MA plus MB bracket, then VV common can come out. So MA is 40 kg plus cart MB is 3 kg into V, as you can see here. MA 40, MB 3 kg. So this we get 43 kg into V. Let us keep this one as equation 1. Then total momentum after is done, so before interaction of the girl with the cart, total momentum before interaction. So it'll be MA UA plus MB UB. So that will be equal to MA is 40 kg into UA is 5. So you write here 5 meter per second, the girl, and the cart is here, so 3 kg into cart before interaction was stationary, so 0 meter per second. 0 meter per second. So this is just a matter of, okay, so 0 meter per second. Okay, if you want to write properly, then here 40 kg 5 meter per second. Now here I forgot to mention, it's not necessary, okay, but let us do like this. Let the girl move from, okay, let the girl move from left to right, left to the right side. Not necessary, but I like to do like this, say, that means we're assuming. So that is this one, plus 3 kg is the mass of the cart into initial velocity of the cart is 0 meter per second. So this will give you a 5 4s are 20, so 200 kg meter per second plus 3 into 0 is 0. So that will be simply this much. This will disappear because multiplied to 0. Equation number 2. So let us do that. Then you can write here the final steps, maybe. Already done. And therefore, according to the law, right? According to the law of conservation of momentum, according to the law of conservation of momentum, we know total momentum, okay, total momentum after or before, up to you. After interaction, if you write on the left, after interaction is always equal to, or after collision, after interaction, up to you. But girl jumping on the cart is, interaction is a more appropriate word, right? So it's equal to total momentum before interaction. So that will be equal to, that implies total momentum on the left side after interaction is this one, before is this one, after is 43 kg into V. So 43 kg into V will be equal to total momentum before interaction 200 kg meter per second. And we can write here since using equations 1 and 2. Okay, so that gives you here V will be equal to 200 kg meter per second, this portion divided by this 43 kg will come down, kg cancelled. So now your answer would be coming here. That implies V will be equal to 200 by 43. You divide 200 divided by 43. 6 3s are 18, 6 4 24. Oh, 6. So sorry, 6, 4, I think, 4. 12, 4 for the 16, 17. 4 3s are 12. Right, so 4 for the 16, 17. So 8 remains here. Here 2. So point means 0. 6 3s are 18, 6 4 24, 25. Then here 10 minus 8, 2. Again 2, so 0 again, let us say. And then 5 3s are 15, 5 6 are 30. 15, 5 4 are 20, 21. So 5 remains 0. 43 into 2 will be too much, so 43 into 1. Up to here is enough, third place. So we're getting plus 4.651 meter per second, which is approximately plus 4.65 meter per second, because third place is less than 5. Here 6. Third place 1 means less than 5, so this will remain same. So we can write here which is positive. This is very important. Okay, so here therefore V is the, if you go back, then you find out that that is the velocity, her velocity. So her velocity after the car starts moving is 4.65 meter per second. Positive means in the direction, or in the direction, yes, in the direction, in her original direction, in the original direction, because positive means she is moving from left to right first. Positive means still continuing original direction. If you like to add, that is from, still it is from left to right. Negative means in the opposite, but positive means same as the previous direction. Okay, so this is 4.65, the answer. One more question before we conclude. Let's do slowly, because this is not hard, but needs some careful solving, right? So example 9.8, this you will find in page 134. 9.8, let me read it for us. Two hockey players of opposite teams, while trying to hit a hockey ball on the ground, collide and immediately become entangled. Means they become like one player stuck. One has a mass of 60 kg, second one has with move velocity 5 meters per second, while the other means second player mass is 55 kg, moving with faster with velocity 6 meters per second towards the first player, means opposite to the first player direction. In which direction and with what velocity will they move after they become entangled? Assume that the frictional force acting between the feet of the two players is 0, means is negligible, means almost not there. So this is what not necessary, but this is helps. That's why I'm putting, okay, let the first player be moving, write it down, moving from left to right. So things become clear to us. Say means we're assuming. Then here we will write MA. The mass of the first player is, I think, 60 kg. Right, yes, 60 kg. And MB, the mass of the second player, 55 kg, are the masses respectively, means first player mass, second player mass, let us say. Then initially the first player is moving with a velocity of 5 meters per second, and the second player is moving with a velocity faster, 0. Now the question clearly says one is moving, first one, A player is moving from left to right, so it will be plus. And they say that two players are moving in opposite direction. This is moving from right to left, so this should be opposite, means minus. This is where we should not make mistake, because the question clearly says these two players are moving in the opposite direction. So if first player is left to right is always plus. So the other one opposite means from right to left, so it should be minus. Are their velocities respectively before getting entangled, or before interaction. You can just do before interaction. Then V, after they get entangled, they say entangled means become one, like one player, so both of them will move with the same velocity. So that is V is equal to question mark is velocity, okay, they become entangled. So velocity with which they move after becoming entangled. Only one, both of them will have V as the velocity because they are now stuck like one player. So this is, that is after interaction, if you want to write. If you don't write also, that's fine for this part. This is what we have to find, okay? So let us do that. Keep it simple and do. Let's write here total momentum after interaction. Let us say after interaction, this is the mass of the first player into velocity, both of them have same, plus mass of the second player into velocity after interaction, VV, because both of them are now moving with same V. That's why there is no VA, VB there. So this common factor you take out means MA plus MB into V. So that will be 60 kg plus 55 kg into V. So 115 kg into V, question number 1. 110, 115. Okay. Okay, so here now similarly let us do total momentum before interaction is MA UA plus MB UB. So that is MA is 60 kg, UA is here 5 meters per second, so 5.0 means 5 only, plus 55 kg, the mass of the second player, into second player is minus 6 into minus 6 meter per second. You may want to put this one in bracket. Just matter of doing slowly. So 5 6 are 30, so 30 and one more 0, 300 kg meter per second, plus into minus, minus 6 5s are 30, 6 5s are 30 plus 3, 33, then kg meter per second. So if you subtract this, you're going to get plus 300 minus 330 means minus 30 kg meter per second. Equation number 2, let us say. See here, minus 330 plus 300 means subtract, so 0 and 3 minus 30, right? So that will give you, once you're through with that, we're going to get here. So according to the law, of conservation of momentum, we know total momentum after interaction, let us say, after interaction. Okay, after interaction or before interaction, which one you want to take first is up to you. Hope you're getting right. Is equal to total momentum before interaction. Before interaction. So let us do that. So that implies here total momentum after interaction is this one. See here, 115 kg, and the V is equal to before interaction is this one here, minus 30 kg meter per second. Right here, since using equations 1 and 2. Okay, almost done. So let's do slowly and patiently. So that gives you here V is equal to minus 30 kg meter per second divided by this 115 kg will come down, so kg cancel. Right, so 5 6 are 30, 5 2s are 10, 1 and 9, 5 3s are 15. So our answer will be coming out 6 divided by 23. So 6 is divided by 23. I hope you're getting it right. 6 is divided by 23. So 0 point, because this is lesser than 2 will go, I think, 46 for 1. Then 1 point means 0. 6 will go, I think, 6 3s are 18, 6 2s are 12, 13, yes, 2 0. Still less, 20 is after putting 0 also less than, means here put 0, 0. So we have reached third place. Well, we can stop there. So you're going to get minus 2.60, or not 2.6, 0.260 meter per second. Third place is less than 5, so we can neglect that, and 0.26 meter per second, which is negative. Which is negative. So we can write for our final answer. Therefore, go back to question. They will, with what velocity will they move after they become entangled? Velocity with which they move after they become entangled, means after interaction, is this one here, 0.26 meter per second, comma, minus means in the direction opposite to the first player, because first player was moving from left to right plus, so minus means opposite. First player, that is from, they will begin to move from right to left. Okay, from right to left. From right to left. So that's your answer. That concludes the test portion. In this class, this 2, 9.7, 9.8, previous class, this 2. So you can now go and give the test, okay? Okay. I hope that's clear to you. Okay.